A regular pentagon with area 1 plus root 5 is printed on a paper and cut out. All 5 vertices are folded to the center of the pentagon, creating a smaller pentagon. What's the area of the new pentagon? Okay, at first it may be a little hard to visualize, but when you think about it, it's going to look like this. The shape's going to look like this, where you're folding along these light blue lines so that each corner is folded to center. Okay. Now, let's not worry about the shape for now, but let's try to investigate or understand the relation between the smaller pentagon with the larger pentagon. First of all, due to symmetry, or since this is folded to this center through this line, this has to be 90 degrees, and this side equals to this side, right? So let me call this side A. So in a sense, A is the height of the smaller pentagon. What is the height of the larger pentagon? So let's try to figure out the height of the larger pentagon. It should be this one, right? So let's call it B. Now, if we can figure out the relation between A and B, then we are done. Now observe that the whole angle of a pentagon is 108. So this half is 54 degrees. So this is 36 degrees. And moreover, when I draw the median of a right triangle, it's a right triangle, then this median also equals to half of the hypotenuse. Okay, so this is A. And this is 36 degrees, if you like. Now let's focus on this little triangle here. And let's draw it here separately. So maybe I should draw it a little larger so that we can, okay, maybe I also draw it this way. This is A, this is A, this is B, this is 36, this is 36. Now, why do we need it, or why are we doing this? It's because the area of the smaller pentagon actually equals the area of the larger pentagon times A over B quantity squared. Why? Because this is the similarity ratio of the heights or of the sides. So the similarity ratio of the square is just the square of this quantity. And we already know that the area of the larger is 1 plus root 5. Then we multiply by A over B squared, and then we are done. So what is A over B squared? So let's find it from here. Now, what I'm going to do is I'm going to just pick a point here so that this is A, right? And then just go draw this triangle. Now, on the one hand, this 36, 72, 72, right? Isosceles triangle. On the other hand, this angle turns out to be 36. And we also have another isosceles triangle here. So this side is B minus A, because this side is A, the total side is B. And so is this side, B minus A. Now observe that this little triangle here is a 36, 36 triangle. 36, 36 is 108 triangle. Also, this larger triangle here is a 36, 36, 108 triangle. So those two triangles are similar. And what's the similarity ratio? One of the equal sides in the smaller triangle is B over A, B minus A, and on the larger one is A. So the largest side on the smaller one is A, on the larger one, or the bigger triangle, is B. So this is just says a relation between A and B. And let's work it. So we have B squared minus AB equals A squared. Then we just do cross multiplication. And then we get 0 equals A squared plus AB minus B squared. When I pull out B squared, 0 equals B squared, parentheses, A over B quantity squared plus A over B minus 1. And then this is indeed A over B is a root of x squared plus x minus 1. So then we can just figure out A over B using quadratic formula, A over B is indeed -1 plus minus root 5 over 2. Since quotient is, or this ratio has to be positive due to side lengths are positive, then we observe that A over B is root 5 minus 1 over 2. So the area of the smaller triangle, smaller pentagon, I'm sorry, is indeed root 5 plus 1 times A over B squared, which is square of this quantity. So root 5 minus 1 squared over 4. And then from, so this is root 5 plus 1, and 1 copies of root 5 minus 1 multiplied to 4 from difference of squares. So we have an extra copy of root 5 minus 1 for the numerator, and we have 4 in the denominator, so 4's cancel each other out. So the area is root 5 minus 1. Let's go back and mark it. Our answer is B.